Okay, so let's just talk about the planet for a second. Why is it so dramatic all the time? What is all this chaos? One day it's a beautiful sunny day, the next day a giant spinning thing is trying to throw your car into your neighbor's house. I mean, the planet has absolutely zero chill. None.
And it's so confusing. You have people running around saying, oh no, a hurricane is coming. And then my cousin from the Philippines calls me. He's like, no, bro, that's a typhoon. Then someone from India is like, it's a cyclone. What is this? It's the same annoying uncle, okay? In one house, his name is Ramesh. In another house, his name is Suresh. But it's the same guy who eats all the snacks and then complains there's not enough salt. It's the same phenomenon.
So the scientists, to avoid all this family drama, they just gave it one boring official name, tropical cyclone. That's it. It's like a parent who has too many kids and just starts calling all of them child. And what is it really? A heat engine. It's just the ocean got really, really hot, and now it's a giant, angry pressure cooker that has decided to go for a jog.
So, you want to make one of these. Okay, fine. But the recipe is so demanding, it's so specific. It's like trying to make your grandmother happy. It's an impossible task. But whatever, let's see how you cook up this complete mess.
Step 1, you need hot water. But not just any hot water. It has to be exactly 26.5 degrees Celsius or hotter. My chai is not that specific, okay? Step 2, this hot water, it needs to be deep, at least 50 meters. This water has more commitment than most people I know. Step 3, a little spin. Earth is always spinning, so that part is free. Thanks, Earth, you're the best. Step 4, you have to kick out the party pooper. There's this specific kind of wind we'll call the judgmental auntie. She cannot be there. And finally, Step 5, it cannot start from peace. Oh, no, no, no. There has to be some pre-existing drama. Some small fight has to already be happening for this big fight to even begin.
So why does it spin? Why can't it just go straight, like a normal person? Well, because the planet is drunk. It's constantly spinning. It has no balance whatsoever.
Look, wind is simple. It has one job. Go from high pressure to low pressure, from a crowded room to an empty room. That's it. But the Earth is spinning. So the wind tries to go straight, and it misses. It curves every single time. It's like a drunk person trying to walk that white line for the police. It just cannot do it. And that is the Coriolis effect. It's the only reason these storms spin into giant monsters instead of just filling the gap.
Which brings us back to the party pooper, vertical wind shear. You see, if the hot ocean water is the fuel for the party, this VWS is the judgmental auntie who shows up to ruin it. A storm needs to be a perfectly straight tower, all stacked up nicely. If this auntie sees the top of the storm is tilted, even a little bit from the bottom, she comes and just pushes the whole thing over. Not stacked properly, she says, and the party's over. Too much judgment. The storm just dies. So for a long time, this was nature's recipe. It was complicated, but it worked. And then we showed up, humans. We're like that one friend in the kitchen who says, bro, just add a little of this, a little of that. And now the whole dish is on fire and the kitchen is burning down.
Now, this is a very crucial point. We are not creating more storms. We are not inviting more of these annoying uncles to the party. No, what we are doing is sending the existing uncles to the gym. We're giving them steroids. So now when they show up, they are bigger, angrier, and instead of just eating all the food, they can break down the door and wreck the whole house. And how are we doing it? It's simple physics, really. Just look at this number. For every single degree of warming, the atmosphere can hold 7% more water. It's like we took the planet's sponge and just made it bigger. So when a storm comes and squeezes that sponge, so much more rain comes out. More fuel for the fire.
So what's the result of all our kitchen experiments? First, stronger winds. The speed limit for these storms is just gone. Second, heavier rain. They aren't rainstorms anymore, they're giant super soakers from the sky. And third, deeper floods. Because we already raised the sea level, the storm surge now gets a running head start. It's like giving a short person a stool to stand on before a fight. It's not fair.
Okay, so that's us. But wait, the planet also has its own internal drama, specifically the Pacific Ocean. You see, it's in the world's biggest, most dramatic long-distance relationship, and its mood swings affect everyone on the planet.
The scientific name for all this drama is ENSO, El Niño Southern Oscillation. It sounds like a brand of soap, but trust me, it's a very toxic relationship. And it has two main phases. El Niño is the warm, dramatic, I miss you, let's get back together phase, and La Niña is the cold, intense, don't talk to me, I'm blocking your number phase.
See, normally, strong winds push all the warm ocean water to one side of the Pacific, like sweeping all the dust in your room into one corner. But during El Niño, these winds get lazy. They just stop sweeping. So all that warm water just sloshes back across the whole ocean. Total chaos. During La Niña, the winds get hyperactive. They start sweeping with way too much force. It's just a more intense version of normal. A very, very unstable relationship.
Now, you might be thinking, why should I care about the Pacific Ocean's drama? Well, because when the Pacific has a fight, the whole planet has to hear about it. It starts sending angry text messages to all the other oceans. It has global consequences.
And this is the seesaw. It's actually very simple. During El Niño, the Pacific is having a big party. So the Atlantic hurricane season is quiet. Why? Because El Niño calls up that judgmental auntie, Vertical Wind Shear, and sends her to the Atlantic. She ruins the party there. But during La Niña, it's the opposite. The auntie is busy ruining the party in the Pacific, so the Atlantic gets to have a crazy one. One ocean goes up, the other goes down. Simple.
So for decades, we knew this rule. El Niño means a quiet Atlantic. La Niña means a crazy Atlantic. It was simple. We thought we had it all figured out. But the planet has been running a fever, a very high fever. And you know, when you have a fever, you start talking nonsense. You forget things. You start to break your own rules.
Okay, so let's just take 2023. We had a strong El Niño. The Pacific was having its big party. So, logically, the Atlantic should have been quiet. A boring season. We could all relax. That's what the rule says, right?
No. Wrong. The planet looked at our little rule book, it laughed, and it was basically like, you think you know me? Hold my beer.
So the old rule was simple. El Niño sends the judgmental auntie, the high wind shear, to the Atlantic, and she shuts the party down. But in 2023, the Atlantic Ocean was so hot, the fuel was so powerful, it basically overpowered the auntie. The heat created its own party atmosphere that was so strong, the wind shear couldn't do anything to stop it. The fuel was stronger than the break, and we had an above-normal season during what should have been a quiet year.
Look, we've given the planet such a high fever that it's starting to forget its own personality. The patterns that we have relied on for decades are breaking down. The whole system is becoming unpredictable. We thought we were watching a movie where we knew the script, but now the main character is forgetting its lines and just improvising. So the only real question left is, what happens next?